Well, the thing that comes to mind most, I love The Simpsons, and it just reminds me of Homer randomly pressing buttons in his nuclear console, and the plant randomly going up in flames. Um, Without the math and without the understanding of the business problem, it's really easy to just push a button and come up with an inaccurate model. And if it's going into production or something like that, and you don't know that you're using the right model and you don't know how to interpret the output from that model and the fit statistics, you can get some really wonky results and it can do a lot of damage. I personally am really happy to see some of these automation pieces because it takes out some of the coding and it takes out some of the more tedious data cleaning. If you can just push a couple of buttons and get a bunch of fit statistics or distribution statistics for 1,000 different variables, all you have to do is look through the output. And something that could be really time consuming to do, just having some of this automation really helps accelerate data science.
So my guest today is a data scientist, computational mathematician whose work bridges statistics, topology, differential geometry, and graph theory, particularly within machine learning. She's also a published poet, a Xennial with an entrepreneurial spirit, and has racked up over 14,000 responses to questions within the Quora community. If you're searching for responses on anything data science, you've probably heard about her. Her name is Colleen Farrelly. Welcome to the show, Colleen. It's such a pleasure to have you here today.
Thank you so much. I'm really excited.
Wonderful. Let's just jump straight into your journey to becoming a data scientist. What was that pivotal moment for you when you decided it was a career path you wanted to pursue and explore further?
So I was actually in medical school. I was an MD PhD student, and I decided to just take a little break from my med school studying and go to this talk. We had just started a genomics department at my school, and there was a talk on random forest applications in genomics. And I remember sitting in that lecture and just completely falling into the talk. And I remember at the end of it, I went up to one of the professors involved and asked, how do I do this? And I ended up switching out of my program, I think it was a week or two later, and just kind of jumped into how do I actually do this and how do I learn this? So it was just kind of one of those aha moments.
Yeah. So what was your first sort of machine learning project? How did you go about sort of developing it? What did you write it in as well?
So my first project was actually right after I switched. I switched mid-semester, so I mainly did a kind of overview of machine learning. And so I just started reading lots of different papers related to genetic epidemiology and kind of how you deal with large data sets with small populations. So I looked at a lot of genetic algorithms because my advisor had done a lot of that, as well as some of these tree-based methods. So random forest, boosted regression, evolved tree models, those sorts of things. And it's really exciting because some of that research that I was doing then on potential applications in genomics, I've actually gotten to do some of this in nuclear physics this past year. So something that didn't pan out at the time has actually come back later in my career as actually starting to implement and explore these methods further.
Wow, that's amazing. Like, so, I mean, there is like a big emphasis on sort of computer science competency or technical engineering competency when you look at a lot of data science opportunities that come up more recently. And that's obviously, that makes sense, rightly so. but obviously with data science, there is a strong sort of statistical mathematical component as well. So, I mean, and you know, you have a strong background in that. What are your thoughts in terms of how can people wanting to break in sort of educate themselves effectively to be just as good sort of coders as they are modelers, and also just be a data scientist that can actually build something that helps someone make a decision, not just fiddling away with code, shipping code, but actually do something that makes an impact in decision making. How can people sort of upskill themselves appropriately from a mathematical sort of statistical perspective, because there is so much focus on the coding side at the moment?
Yeah. I think it's really important to understand the application, so the field that you're working in, whether it's healthcare and understanding some of the nuances of healthcare, or in the social sciences, just understanding some of the theoretical material behind where the data is coming from, as well as the math. There are a lot of really great math resources out there. I think there's actually a lot more math for engineers, math for programmers than there is coding for mathematicians. Speaking from experience, you know, you've got Khan Academy, which is great for some of the foundationals. Like if you haven't had calculus and linear algebra, that's a really good resource, and it's free. So that's always good. Lots of books out there. So the Demystified series is really good. Just a lot of either free or mostly free resources out there of just low cost books, online kind of high school oriented type enrichment things, like Khan Academy. A lot of those can be really useful for skilling up. And once you understand kind of those fundamentals, there are a lot of really good textbooks out there. Elements of Statistical Learning is one of my favorites. It's one that I went through. And having the calculus and the linear algebra and a little bit of stats that you can get from like Khan Academy, or even just reading online, it's enough to really understand kind of the basics of how machine learning algorithms are derived. A lot of them, it's really just the calculus and the linear algebra, and you know, there's not much more math to a lot of methods.
So, I mean, on that vein, then, you know, if someone said, you know, I don't particularly love maths, but I want to get involved in the data science scene, especially because I'm hearing more and more that AutoML is coming in. So, do I really even have to understand what's going on, since there is a lot more that I can do with these tools? Like, what are your thoughts on AutoML, and what are your thoughts on probably the most important aspects to focus on to make yourself a little bit more job secure for the future as a data scientist?
Well, the thing that comes to mind most, I love The Simpsons, and it just reminds me of Homer randomly pressing buttons in his nuclear console, and the plant randomly going up in flames. Without the math and without the understanding of the business problem, it's really easy to just push a button and come up with an inaccurate model. And if it's going into production or something like that, and you don't know that you're using the right model, and you don't know how to interpret the output from that model, and the fit statistics, you can get some really wonky results, and it can do a lot of damage. I personally am really happy to see some of these automation pieces, because it takes out some of the coding and it takes out some of the more tedious data cleaning. If you can just push a couple of buttons and get a bunch of fit statistics or distribution statistics for 1,000 different variables, all you have to do is look through the output. And something that could be really time consuming to do, just having some of this automation really helps accelerate data science.
Right. So from a skills, I guess, I mean, this actually feeds in quite well to another sort of question I had for you, which was I was listening to a lecture recently from someone within financial services, and they were talking about how they had some models put into production with a very poor sort of R-squared figure. And these models were running, and the explanation was, well, we have some explainability. I mean, it's not ideal. And so my question was more, obviously, if you're borrowing someone $10 and you have a poor model in production, it's not that big a deal probably. But if you're borrowing someone a substantial amount of money, or you're making a decision on whether somebody goes to jail or not, if people are able to get away with building these models, what can we do to sort of improve the situation? And is anything being done? How are people getting away with putting things like this in production? And I guess how much of data science is actually being able to sort of story tell your way effectively through the situation, which, I mean, it seems quite dangerous. But I guess my question really is it the data? Is it the scientists? And can we do something about it?
I think it's a lot of factors. If you don't have good input variables, like I've seen models where literally nothing in the data is related to the outcome, that's a really bad model. That suggests that what you think is important actually isn't important. And while you might get some good prediction, so something with a low R-squared might actually have decent prediction on something, but if it's built mostly on this error, it's pretty dangerous to have that making decisions. I would say it's pretty dangerous to have algorithms in general making decisions. We just don't know enough about this, and taking the human being out of decision making can be really dangerous in certain things. So in healthcare, in education, I would say also in the financial services, since this is people's money, any of these things where people can potentially be harmed by something making a wrong decision, you want to have a human in the loop. You want to have a human using the output to make decisions rather than a machine making the decisions. Otherwise, you run the risk of, the world being taken over by a sweater folding machine that goes haywire and starts folding everything.
Right. I guess the argument then would be, can humans scale on that level? We can get so much more done with automation. Why don't we just try to improve the algorithm? Is that ever going to be the case where, do you think that's ever going to be the case where we completely run on algorithmic decisions, or will it always be this fusion of human and computer working side by side to make the best possible decision?
I think it's really humans and AI working together. So I'm not sure what the company was, but one of those self-driving cars that didn't train on bridges, and the car did not know what to do when it came to a bridge and just suddenly stopped. So you have things like that, and having the human in the loop allows for, hey, we didn't train on this particular situation, because really there is no way to train an algorithm on every possible situation that it might encounter. And so you're going to have some situations or some individuals or groups of people that the algorithm doesn't work very well for. And that's when you get the human involved. Maybe there's a little red flag that comes up and says, get the person. But I think, at least in my lifetime, automating everything and having AI making the final decisions on things just isn't going to happen.
Mm-hmm. No, that makes sense. So I know you've been involved quite a bit in the African tech sector. Would love to hear exactly what you've been doing. Is any of it data science related, and what's been your involvement so far?
It's kind of a funny story. I actually got started when I was in graduate school. I had a friend doing business in Mali at the time of the Ebola outbreak in 2014. And he was concerned about his employees who were kind of traveling from border areas and wanted to understand how Ebola might spread to the country and what could be done. So I ended up working with him and with the health ministry to run a few what if scenarios of kind of, okay, here's where the most likely entry points are, here's what sort of resources would need to be diverted. And I kind of started getting involved that way and have been involved in some other disaster projects, just with friends who do disaster response, those sorts of things. And most recently, I've started getting involved with Data Science Africa, which is this awesome group of tech folks who are either from Africa or working in Africa or from Africa and working in Africa, on a lot of really cool projects.
Yeah.
And it's been really cool to connect with other researchers and PhD students and industry folks on all of the really needs-based projects that are going on. So how do you create chatbots that speak native languages? How do you fill in the gaps with Google of not having a lot of native languages in their translate services? How do you optimize certain agricultural techniques or routing of resources? It's really exciting to see just how much the tech sector is really growing these days.
I've actually had some of them write for the Mathematician's blog as well, some of the things you've mentioned. Very interesting. So, I mean, there is a lot of going on generally within the African tech sector. And as you're saying, particularly within the data science sector, what advice would you have for people wanting to break in, even from, non-coding backgrounds? And given where they are from a life cycle perspective in terms of data science in Africa at the moment, what do you think are sort of the best strategies in breaking in? And I feel like there might be a lot of people wanting to do more startups over there as well because of the way the ecosystem is framed. So what are your, can I just march out without any prior, data science experience and do my own thing, lots of MOOCs and YouTube? Because people will try. People will try to utilize as much resources as they can from the web, but what would your advice be in terms of making sure that you're going through a good process to build a solid foundation?
It really depends on where you are. In some countries, South Africa, even Ghana these days, having a degree is really important. In some of the tech sectors that are still really developing or don't have university programs, getting a degree in something and then kind of doing the MOOCs can be a good option. So you have the domain expertise, plus you have the data science, and there might be an opportunity to be one of the first in that industry in a particular country, kind of doing those things. There actually are some good math-based PhD positions that are available. So I've been connecting with a Cameroonian researcher kind of in my area of topological data analysis. And so those positions are out there. It just kind of depends on the country and how things are structured. Some places are really startup friendly, like Kenya. So it really depends on the country and kind of what positions are available. The government positions are usually less flexible with educational requirements. The more startup scene might not pay as well, but it's a little more flexible with entry.
Yeah, you mentioned PhD positions when you were speaking, and actually reminded me, this is a question that comes up a lot, even just generally, do I need a PhD to break into data science? Now, I know a lot of people say no, but then I do wonder, there are jobs that specify that they want it. And so I'm just curious, like, what is the value of having someone with a PhD? Is there something that you learn through that process that they bring into a data science opportunity that's like valuable? And do you have to go through a PhD to learn that?
It seems like it's a lot like academia. With the PhD, you're going to find positions that are related to your research area. And you're going to be doing that in industry, and then your resume is going to be very unidimensional, I guess. It's great if you really love your research area and hey, I want to do innovation in NLP, for instance. You know, maybe you can go and get a job working on Alexa, or some of these other new applications, you know, Google Translate or something like that. It's really great if you're aiming for something like that. If you want to work in industry and have a wide variety of interests, I'd suggest the master's. I know I've been penalized a bit just having the master's, but having research combined with the master's is usually enough, especially with some experience. It's usually enough to make up for not having the PhD. But generally, I find positions that are really inflexible on requirements generally aren't places where you'd really want to work, especially if you're starting out. There's a lot that isn't known about data science, particularly within HR departments. And so you get these really weird job descriptions of, oh, hey, 10 different languages, 20 years in a field that isn't that old, you know, an MBA to boot or something like that. And generally, those type of situations, you probably don't want to go there unless you don't have other options, because they probably don't know what data scientists do, and you might end up in a position that's not actually data science.
Wow, that's great advice. So, you know, you have a multi-dimensional career so far. I know that you're doing consulting work yourself within healthcare, and you spoke briefly about your involvement earlier in the Ebola outbreak in terms of modeling outcomes and things. So I'm quite curious, you know, what have you done in the present sort of COVID situation? What has your involvement been, if any, in industry? And also curious as to whenever we talk about predictability during the outbreak process, there is a lot of emphasis post it's occurred, and we're trying to predict outcomes of what we should do to manage the situation. But I'm quite curious, and I think other people are as well, is there a place and is there any work being done from a prevention perspective where we could actually actively model the potential of an outbreak before it's an outbreak? And if there is work like that, I'm curious, what kind of features are they using to basically sort of build that signal? So I'd love to hear your thoughts there.
So I actually have worked on outbreak planning scenarios. I have an algorithm in one of my startups that kind of looks at risk, mostly using kind of the stochastic differential equation approach. That you can actually model given known or theoretical type of outbreaks and the parameters, you can actually model it with a wide variety of tools out there. Differential equations, we know so much about how things spread. You can do compartmentalized models, you can do more of the stochastic models, you can do network-based models, and really understand, you know, given a particular type of disease and a particular structure of a community or a nation or the world, you can really understand the potential for an outbreak. And this has been known for quite a while. It was just a matter of time for something like COVID to happen. I'm just glad that it's not as deadly and it's not as contagious as some potential diseases. Basically, the dynamics of COVID, if you had more like a 20% death rate, that's kind of the ideal bioterrorism type weapon. So it doesn't kill super lots of people, but it overwhelms enough that it creates, you know, a much worse scenario than this, where you can't just do social distancing and avoid overflooding hospitals. But the contagiousness, the airborne part, all of these different parameters kind of feed into these models, and you can understand like what it would potentially do to political situations, social infrastructure, those types of things. And it's really possible to model these different things and entry points. So is it coming in by planes? Is it arising in some rural area like hantavirus, where you have a rural area with mouse droppings. You know, how are these diseases really evolving? How are they getting into the population? How are they spreading? We know a lot at this point with disease modeling, and I think hopefully out of this, there's more emphasis on understanding the potential risk before it gets here and before there's mass panic and a bunch of kind of knee-jerk reactions to things. Like down here, it became quite a bit of a mess when we realized it was down in Florida. My area, Miami-Dade, ended up actually shutting down schools without having other options for students on school meal programs. So like 70% of our population is on federal meal programs through schools, and they were left without food for a good 7 weeks. So, you know, understanding this stuff before you get into those situations allows you to be able to have a plan before it becomes a problem and before you need to enact a plan.
Wow, that's a lot. I mean, I think what's also great about this situation that hopefully has come of it is there are more people just getting involved in data science COVID projects just from a volunteering perspective, not necessarily even as a job, because everyone can contribute in some way. Actually, are there any sort of places you'd recommend that would be useful for people to want to get involved in projects like that you've seen if they want to contribute their expertise or get involved and help out?
Well, I do know that there are a lot of open source COVID data sets. I believe Data Science Africa actually has a COVID data set for folks who just want to, you know, do a first data science project, or somebody in the field who wants access to data. I know the US has a few of those as well. One of the sources that I really like is Humanitarian Exchange. I'm not sure how much they have on COVID, but they've had a lot on other outbreaks like Ebola, of tracking cases in different parts by time. That really gives you enough to start tinkering with models.
And I mean, on the subject of data, actually, you know, typically you hear, you know, your results are only as good as your data or your data source, etc. How do you sort of manage that the quality of data that you get for the project you're working on is good? And as you're modeling, how do you manage things like bias coming into your model effectively and making sure that the quality of what you're building is good or reliable?
Well, unfortunately, with a lot of legacy systems, it's not realistic to know ahead of time whether or not the data is good. So working with stakeholders to understand how the data was collected is important. So sometimes you might see something really weird in the data, like you know, negative finances or something like that. But what's being calculated is a formula that you wouldn't think of using. That's creating negative values that aren't actually negative values. They're just computed that way. Or, you know, in healthcare, sometimes, you know, it might be in more of the US measurements, so pounds instead of kilograms. And depending on which data set you're working with, it might look a little weird, but it may be that it's going through a system that does the conversion or something like that. But when you're starting a project and you're kind of digging in there and it's like, okay, you know, these look like reasonable values, there aren't too many outliers here. It's probably a solid one, assuming that it's being collected the way that you think it is. But then again, sometimes data can actually look pretty valid, but it isn't. You know, somebody set something up and it hasn't been looked at in a few years and it's still collecting things, but it's not collecting what you think it's collecting anymore. That's probably one of the bigger challenges in data science, is just collecting the right data in the right way so that it's usable.
I know that another aspect your startup focuses on is you've been involved in quite a few marketing projects, for example. And I mean, I'm speaking broadly, but when we think marketing, I think one aspect that typically concerns general population is the data that companies have about them can be used to manipulate their decision and choices, without them really actually knowing that they've been set up to want something, or want to buy something, or want to do something. How do you think, how do you as a startup company sort of ensure that you're thinking about the ethics behind what you're doing, from a modeling predictability basis? And generally speaking, how do you think, how important is ethics in the whole sort of general data science conversation? It's not a big part of data science curriculums necessarily at the moment. So how are people going to be conscious of it? Is it a problem? Just, curious what your take on it is.
It's a big problem. Some of it, I think, just is, some people don't have as solid of ethics, just from their background, and some, I think, is just not taking context into consideration. I'm a big advocate of learning sociology, and knowing some of these potential biases that can end up in data. One of the ones that I looked at, not really with machine learning, but more the statistics, when I was in undergrad, I did a lot with criminology and legal bias. So if you're training a model based on prior data that is biased, such as sentencing disparities, if you're trying to use the data that already exists to try to figure out how long you should sentence somebody or what their reoffense rate might be, and you have the biased police department or legal system in a certain area, you're going to end up with a model that, one, isn't accurate because it's trained on biased data, and two, is going to continue to do harm to a community. And I would love to see more ethics, maybe situation-based ethics courses in data science. So, if you're in healthcare, like, what kind of error is okay? It's not even completely an ethics question. It's more of, which mistake is really going to hurt the most? Is it better to, catch every Ebola patient but unnecessarily scare some people? Or is it more ethical to not scare a bunch of people but potentially have a bigger outbreak? It's a hard thing. Mammograms, for instance, huge false positive rate. And that was one of the things that kind of drove me a little bit nuts in med school, that the Bayesian reasoning about problems is sometimes off. If you have a huge population and most people are negative, a lot of your positive tests are actually going to be true negatives, even if you have a really small error rate. Just the numbers as they work out, you're going to get these huge populations that are scared, even if you have a pretty good test. And I think we're seeing that with COVID. Some of these errors in the tests, you might have a fairly accurate one, but yeah, you're missing cases, and yeah, you're unnecessarily scaring some people. And that has big implications in society. So I definitely think we need to have like scenario-based ethics classes where you really dive into like the impacts of what you're doing.
It's interesting that you mentioned sociology there, actually. I was reading something recently by the chief decision scientist at Google, and she spoke about how social scientists are better equipped in comparison to data scientists to translate intuitions and intentions of decision makers into concrete metrics. So there seems to be this sort of new sort of coined term of the social data scientist, and I even saw a course pop up recently about a year ago or so that's been run at a university in Europe, for example. What is social data science, and why should we care about it?
I have not heard the term social data science before. Like most data science courses these days, I'm not sure that there's a whole lot of consensus But understanding the social context is really important. Understanding some of the psychology, understanding group differences and bias is really important. It's hard to really understand the problem unless you understand kind of how people might use a product, how people might use the results, if there's anything feeding into these results. For instance, in educational data, particularly little contentious of a topic, but looking at the impact of charter schools on low-income educational attainment. Knowing to look at gaps rather than absolutes. That's something that I've seen in a lot of different projects. So you might not catch up completely in something like in healthcare, you may not completely close the gap between disease or non-disease, but if you have a 60% improvement versus a 20% improvement on a different treatment or in a different school, you know, that's a huge difference relatively for the person that's being impacted.
What I'm hearing from a lot of what you're saying is potentially someone that actually has really strong domain expertise in an area, then goes to pick up the coding skills and understands the modeling, is potentially a really strong data scientist in comparison to someone that just did a statistics course and knows how to use Python and R and is just throwing a bunch of models and just, yeah, this is the outcome of what I think it is, saying that domain expertise is actually really important.
Yeah, and I'm hoping that the field continues to kind of go into this. Okay, we have a biology project that involves complex systems. Let's hire a neuroscientist who knows some Python and knows, you know, has had some computational stats type classes over, hey, you know, let's hire this person who's super awesome at this coding language and all of this, but might miss, you know, important parts of the problem.
This is such an interesting conversation, because talking to hiring managers, it's one thing, they want to ship stuff, they want to get things in production, but at the same time, it's like the end interpretation of someone that isn't necessarily a strong coder but understands what they're doing to help decision making. Isn't that more important? I don't have the answer, but I just know that this is like a reoccurring sort of conflict of who is the best person to pick for the opportunity.
Yeah, I think it really depends on the situation. I mean, if it's just a general problem and there's not a lot of domain knowledge that you need, I can see hiring, you know, a software engineer who learns some of these techniques. But at the same time, I can see, you know, in specialized sectors, having somebody who's an expert and then getting the resources to train them into being a coder or training them in a specific technique probably makes more sense. You've got the domain expertise plus some technical skills, plus with all of these conferences and certifications and courses out there, you know, you can pick up some of that, especially if you're on a team with folks who know that. I do think that the domain expertise is probably one of the more important parts of data science. And probably why we don't see people changing sectors too often. It's usually tied to something that you learned in school or experience that you've had, you know, 5 years of experience in a field. You kind of know some of the caveats and problems and regulations. And having some, you know, educational background or something, you're able to more quickly pick up something like, you know, the physics project that I'm involved in. I have a background in some of the physics courses in undergrad, so it's easier to just kind of jump into some of the domain having that background already.
Right. Actually, on one of your startups, I know you're involved in like a nuclear reactor optimization project, which is very different from the healthcare. You've got the marketing. How did you end up sort of on that project, and what are you trying to optimize or predict or analyze there?
So I'm looking at a couple algorithms with a team of researchers kind of looking at rod configurations within reactors. So right now it's a toy problem, and we're hoping to go to some of the actual smaller nuclear reactors in the next year. Kind of looking at how quantum computing and different types of machine learning algorithms can actually find good patterns within the rod configuration. So you kind of have the trade-off of you want it to be efficient so that you're not wasting really expensive resources. So these rods are like a lot of money. So you want to get as much life out of them as you can, but at the same time, you know, certain configurations you really can't have because, you know, boom. So you kind of have the safety trade-off with the lengthening the amount of time that you can run these things and lessen the waste that you're getting out of a reactor. It's been really interesting. It's a team of industry folks, academia, and then my business partner and me. So that's been really interesting to kind of see how all of these pieces fit together and kind of diving into the problem.
Is there anything distinctively different about how you approach this in comparison to the other projects that you do typically?
I think with this one, there's more kind of the quantum versus classical going on. So there are a couple of fields where quantum computing is really well suited to solving problems, particularly in chemistry and physics, because you actually have, you know, atoms being involved in the project itself and the problem. And quantum computers kind of can do a lot of those things natively. And it's been interesting to kind of see how classical algorithms handle this, and it'll be exciting to see the runs from the quantum system that we're using and how those compare. It's a really exciting time in quantum computing.
Wow, amazing. It's such a different aspect to be involved in compared to everything else you're doing as well. It must be very exciting. Now, another aspect to you, Colleen, is I know you're a published poet, and I actually recently came across a project at Cornell University where they're doing some sort of neural model on poetic language, and they've called it Deep Spare. So they take like a Shakespeare, you know, project, and it can actually do something quite similar and comparable to it. Have you come across that? And if you have, what are your thoughts on that?
I haven't come across much of that. I know there's like automated text generation and some of those things that have variable performance. What I've mainly seen is being able to extract information from text a little bit more than actually generating works of art type deal. There are actually algorithms that can help understand works of an unknown author or potentially a group of authors, and being able to look at the diction in the work and specific use of pronouns and other parts of speech can actually help you figure out who wrote this. It's been applied to the Federalist Papers. So some of those are known to be written by certain founding fathers, and then there are some where there's been contention over who wrote it. And there's actually been research done kind of in the psycholinguistics space of uncovering some of these mysteries, uncovering things about Shakespeare, for instance. A lot of contention over whether he existed, if he was a couple different people, if somebody was writing under his name, and being able to kind of uncover this insight about historical documents is pretty interesting and powerful with machine learning.
Fascinating. What for you, generally speaking, more has been like the most sort of surprising discovery you've had and unearthed in the process of scrolling through data for your projects?
I think probably the most interesting project that I had was a genomics project. We were competing in Genome England and looking at ways to kind of merge symptoms that a patient had, diseases, and gene data, so genetic testing or GWAS data. And being able to fit in the missing piece was really interesting, and kind of looking at incomplete data in networks and how do you fill in that information so that you have a complete data set. Because one of the big problems is if you have incomplete links in a graph and you try to do inference on it or matching type algorithms, it can be really off if you don't have those links. And it was just really cool to see how accurate the system was when I was able to figure out the final piece and we were able to assemble that into like a master algorithm. It was so cool hitting those tests and seeing the results and how accurate the top 5 lists for the disease was. Right. Even just based on symptoms and what genes might come up. And it was really cool to see all of those pieces coming together and how AI can actually really help accelerate research. Yeah. You know, you can generate a bunch of hypotheses by putting in, you know, hypothetical cases and seeing what the system suggests as possibilities. You know, new genes to look at for what's causing a particular disease. What types of diseases you might see from, you know, errors in a random gene. It's really interesting.
Like a lot of this work sounds like it's going to end up prolonging human life more significantly, because when you get to the point where you're now doing preventative medical care, where you're preempting based on your genomics, what diseases you have a percentage rate of getting within the next X years or whatever, like the type of problems we're going to need to solve also will change in certain industries. Like, will there be enough space on Earth for the number of humans we'll have by then? And it's just very interesting how it just really propels humanity forward to keep improving in the area of AI. It just affects so many things, and it's very fascinating to hear that.
Yeah, and that's actually one of the things that I've looked at a little bit. While I was at this genomics company, the scientific advisor was also involved in a human longevity type project, looking at the elderly. So doing genetic analyses on really healthy older populations. And my grandma was actually a participant in there. She's 98 and she hasn't had problems with cancer or heart disease or dementia. And so this study, particularly with her population, looked at really old people. Sorry, Grandma. People in their 80s and especially 90s or 100s who haven't had these major issues of old age, and trying to use them as a way to understand what genes are contributing to aging well. It's actually pretty common within the genomics sector. Extreme phenotypes are what they're called. So a strategy of looking at an extreme phenotype, like healthy old age or super high intelligence or something like that, and comparing across an average population to better be able to see the differences, so you get more statistical power and more discernment when you're using machine learning methods. If you have these extremes, you have bigger effect sizes, essentially.
I'd love to get more details on that, and I'll link it in the podcast as well for people that might be interested. I think that's really fascinating.
Yeah, it's amazing what machine learning and statistics can do these days. We just have massive amounts of data on pretty much anything. And even just being able to do DNA analyses these days, I mean, it doesn't cost that much to be able to do some of these studies. It's really amazing how fast technology has moved and how feasible things are even compared to 10 years ago, for really being able to collect all of this data and look at all of this data at low cost, even store this data at low cost.
Yeah, yeah, I totally understand. So, I mean, we talked a lot about, you know, what makes a good data scientist, how we can break into it, etc. What do you think is most difficult, or what are some of the most challenging aspects of being a data scientist in your experience?
I think applying for jobs, I would have to say. There's just so little known about data science outside of, well, data science, that it's really hard to know if you're getting into a good situation or not.
Right. Like,
You know, job descriptions
yeah.
might not actually match what you're doing, and hiring managers might have no clue. There are different expectations of what your resume looks like. There was one company that I was applying to the last time I was looking for jobs, and like basically the hiring manager just scheduled an interview with me and just reamed me out the entire time about how horrible my resume was and that I'll never be successful at anything in my life, and just like all of these horrible things. And it was like, okay, I have my resume kind of half business, half CV because I do both.
Right. Of course.
Needless to say, when the VP called back and wanted to like go on, it's like, I'm never working here and never recommending this to people. But just you have these extremes of situations, and then you have the people who are hiring their first data scientists and don't really know what they do. You need the infrastructure for a data scientist to be successful at a company. You need data to exist. You need data to be usable, accessible. If you're spending all of your time trying to make the data accessible, you're not going to get much out of your data science projects because you're not doing data science projects.
Looking at it from the other side, so if someone is a HR person, typical gatekeeper, or even like a hiring manager in a startup, what do you think they should look past on a resume and really look for in a resume to get the right person shortlisted? Because sometimes a HR person typically has like, okay, do they have a university degree? Do they get a good grade? Do they have a STEM degree? You know, do they have Python? I don't want R. And they're just looking at the resume in that sort of tick box fashion. So for them to do a better job, what do you think they could do to improve how they read people's resumes?
I think first of all, it would be helpful for more MBAs and executives out there to understand what data science is. There are a lot of good introductory courses. I've written an article, Data Science for Executives, I think is the name of it, just kind of explaining some of these buzzwords and when you need them and when you don't. And I think that would be really helpful for the people at the top to really understand what a data scientist is and what they do. It's not a programmer position. It's not a typical marketing person type position. I think that would help a lot. And I think it would help a lot with helping HR understand what exactly they're looking for. And I'm also very against these algorithms that are used to screen resumes. If you're missing a buzzword that's not going to be relevant to the position, you shouldn't be screening people out. And I think it's one of those things that really disadvantages certain people. If you know how the algorithms work, if you know how cultural screening works and all of that, you can tailor your resume to get better hits. But if you don't have that knowledge or you don't have that cultural background, you're just at a disadvantage. And I think it just amplifies the lack of diversity in tech. Certain people know the buzzwords and they're putting it on resumes to just get past screening. Or you can theoretically do something like that. So I think that would help a lot if there's less of the screening and there's more actual understanding of what's important. it's easy to screen a resume once you know what's important and what you actually need to be able to write something yourself and do that.
So what advice would you give to someone wanting to pursue a similar career path to yours, in a sense of they want a career, but they also want to be able to get involved in some of these startup type of projects as well? So what would your general advice be to them?
I think it works best if you're doing some things on the side, rather than just kind of jumping into something high risk, especially if you don't come from a wealthy family. One thing I've noticed with these startup competitions and things is it's a lot of 22-year-olds with a tech degree who are on their parents' insurance, living at home, don't have to worry about these things. It's a lot easier if you're working in a position and you're able to do something on the side and you're just kind of easing into it and getting your feet wet before really jumping into it. I think that's probably one of the big reasons why a lot of tech companies fail. It's a small group of people who really can't dedicate the time and resources to a company full time who are trying to do that full time. And it's just stressful if you don't have what you need and this is the only way that you're going to get it. So I would really advocate kind of doing things on the side to start out with.
Excellent.
There's plenty of time when you're 40 to have a startup or two and just be doing that.
Yeah. For you, what have been the sort of three most either people, books, or ideas that have been the most influential to you, and why?
I would have to say probably my college German professor, Dr. Pusto. I was one of those students who came very different culturally from a selective university, and I had the worst freshman year that I think is possible, and he stopped me from dropping out. I was ready to never come back to education, and without him, I definitely would never have, stayed or ended up on this path. And it was really cool. Like when I got inducted to Phi Beta Kappa, he was the dean who was inducting people, and it was just one of those great experiences to show him like, here's where I am, and I just got accepted to this graduate program, and thank you so much for like letting me be able to have this awesome career.
Fantastic. Any sort of resources you would recommend that have helped you along the way? Like I hear you're writing a book, something to do with machine learning, I believe. When is that scheduled to be published? Can you tell us more? And just any other resources you think could be useful?
We'll see. There's been some hangups, especially with the pandemic, of reviewers and other folks who are involved. It's really involved writing a book. Like there are a lot of moving parts.
Right.
And if one of those parts, drops off or leaves the project, it takes a while. So I'm not sure when this will be published. I know we're behind when they were hoping to kind of get this out. So hopefully 2021, I think is the new date for that. I would say if you're starting out, really make sure that you're surrounded by good people who are really knowledgeable about whatever you're doing. Like I love my publisher because they really take you through the entire process, and by the time you're finished with the book, you really know the ins and outs of writing a book and all of the different steps that are in there and what to expect at every step. And I would really recommend that if you're branching out. Just find somebody trustworthy who's really going to be involved in the process with you. I think that's important for any sort of mentorship.
I mean, that's an interesting one. I've been seeing more of these mentorship type of programs being set up. What do you think about them? How can you make sure you're being mentored by someone that's actually good as well?
I think formal programs are probably best. So if your company has something and you're not in a data scientist position, but you can get paired up with a data scientist, I think that's a really good way to learn. that was something one of my prior companies, there were engineers who were interested in data science, and being able to kind of show them some of the algorithms and some of the caveats of algorithms, I think was a really good collaboration on some of the projects. So something like that within your company can be really good. Also, if you're in one of these MOOCs, or you're in, one of these boot camps or something, getting paired up with one of the TAs or the teachers, I think can be really valuable. Once you have kind of that personal relationship, it's easier to be able to kind of establish the mentorship. You can have somebody super qualified that you really just don't click with, and it's not going to be a good experience.
True. Colleen, where can our listeners connect with you online? What's the best sort of resource point to get in touch with you or hear more about what you're doing and what you're up to?
You can message me on Quora or on LinkedIn. Just mention this podcast, please, because I get a lot of random things on there. But if you mention the podcast, happy to connect with you, and probably going to click the yes and respond to you.
Awesome. Thank you so much, Colleen. It's been an absolute pleasure speaking to you this morning. Wish you every success with your data science career, startups, and the book as well. I look forward to hearing more about that, hopefully in 2021.
Thank you so much. This has been so much fun, and thank you for having a podcast like this.
Awesome. Have a great day. Take care.
You too.